Good morning, my name is Matt Starr, Chief Technology Officer for Spectra Logic. I'm here to talk to you about some of the issues we're seeing with tape in an archive environment. The archive environment is slightly different than the backup environment. In the archive environment, you write a tape once, and the possibility that you'll need that data back diminishes over time. So you write once, it's a read maybe or read often type situation. As in a backup environment, that's where you write the tape, append to the tape, and continually use the tape, recycle it, write it all again. Archive, you really only write it once, and then the probability of restoring that tape degrades over time. So let's first talk about how media is made. Media is made in a webbing and slit fashion. So what they do is they take a large piece of media and they cut it into small little strips like this. So the media is built up, basically it has a backer, then a piece of magnetic coating, a hardener, and possibly a lubricant. And everybody's media formulation is slightly different. But this basically large piece of webbing or a large piece of jumbo is built in this fashion, and it has to be slid up into tapes. And what happens to slit media is they run these rollers across the media here, and these rollers are what are cutting the media. And the roller shape is shaped like this. And you can see right here that we have a piece of media that's going to be cut right here, and you end up with a little half-inch piece of media that looks like that. But if you look, we're kind of cutting it with a wedge, and you never really get a perfect cut. So what happens in this case is you're going to get a piece of media that is shaped something like that. Instead of being perfectly flat, it has a little bit of a up kick on one end and a down kick on the other one, and really kind of like that is probably better. So when you have a piece of curved media, the other thing that's going to happen there is a little bit of debris. When this cutter comes in here, is going to pop up and build up here, and a little bit more debris here, and possibly a little here and a little here. And that debris is called slitting debris. So you take a new piece of media, you've just cut it. The next thing they're going to do is they're going to run it past a cloth under here. This cloth is basically running right here, and it tries to clean this slitting debris off the media. It's a very soft process. But you have a magnetic particle and a magnetic piece of tape, and when they come together, they actually stick quite well. So there's always slitting debris left on the tape. And you have a little deformation in your tape here too. So as the media now comes into a tape drive, you have the capstans, the head, the tape comes by like this and comes out right here. All that slitting debris is going to start building up on the head. And what that means to you is in an archive environment, the first time you use a piece of media, you're very low on the signal-to-noise ratio. So in other words, you're getting a lot of noise on the head versus the signal you're actually getting. And over time, as you move out to 1,000 passes past the head or to 5,000 passes past the head, slowly but surely the signal-to-noise ratio climbs. And so when you get out to this area here at 1,000 and 5,000 passes by the head, the tape is actually getting honed in or tuned into the tape head itself, or any head itself, being cleaned off, and it's actually kind of getting closer to the head and getting a lot more or a lot better signal-to-noise ratio. This is a problem in the archive environment because you're writing the tape the first time and then you're reading it. And you're writing it down at this portion, not this portion. And so Spectra Logic is looking for solutions to this problem with their MLM media so that we can solve the archive environment by getting you out of the low signal-to-noise ratio areas and into the high signal-to-noise ratios down that first write. Thank you very much.